So we welcome now to the to our weekly program after the short break post summer training. So the topic we are going to be starting with, as we can see, is taking benefit of machine learning modeling, irrespective of your background. It doesn't matter where you are from, irrespective of your background. Oh, I am not computer literate. It doesn't matter. I'm an engineer, irrespective. That is the world. So you can take a lot of benefits of it, and the world is looking forward to what you can use this fledgling technology to achieve. So I say that it is time to take action. You see, we had an episode where we said, do it right, or make sure you are doing it right. But this episode we're starting with, it is time to take action. That is, practice as you learn. Practice as you learn. This topic is very, very important based on some of my recent interaction with our members. We had members that have been with us for a couple of years, but don't be only able to, they just started implementation or practicing what they have been learning just a few months ago or some months back. And you know, no matter how much you learn, if you don't put it to practice, whenever you want to practice, it's as if you are starting afresh. So a lot of simple questions has to keep coming. How do we do this? How do we do this? You're all welcome. But what I mean is we need to do that as early as possible. You see, machine learning and data science stuff is a thing that the more you practice, the better you become. So don't just listen and then you keep it. Next week you come and listen. Try to practice something. This is what we want to encourage all of us to do. Start. In fact, for those that just join us in the WhatsApp group, there is these 7 videos, 4 revision videos introducing you to machine learning. If you can listen to the first 2, then go to when I said, welcome machine learning model. That is the first machine model in your life can be built within the first few hours of your learning if you follow those videos. Okay? Just follow the instruction there. It's so self-explanatory. Some of our interns demonstrated this. Within a few days, they started doing their modeling after watching those videos. So, and then as you are watching them, as you are trying to practice, questions will be popping up. Keep writing them down. Keep writing them down. Note those questions down. That is one of the essence of this weekly engagement. So that those questions, we are going to be giving more time to those questions now. You see, we'll be having early section to discuss basic issue, new concepts, additional clarification. However, we would like to be spending more time on your question, clarification, because we want you to practice as you learn. That is, as you are learning the concept, we want you to go and use it, practice it, and see the way you can practicalize. So this is the basis of this, and we are going to communicate it also in the group, and this video also will be made available on our platform so that we, no matter how much theoretical knowledge you've gathered, if you don't start practicing, that's why I give an hypothetical case of someone who has been with us for long, but when she started practicing, she faced a lot of issues. You see, of course, we were answering, we were responding. Just take a screenshot. How do we do this? We respond to it. Either I do that myself or one of our team members may do that for you. But you're always welcome. Now, she's very much comfortable. See? And we had people just started like 6 months ago. Today, they are like a professional. Now they can pick any problem, build their model, write research paper on it, and you think that they have been doing it for several years. That is the power of practice as you learn. And this is what we want to encourage everybody on board here and anyone that's going to listen to this video elsewhere to do. As you learn machine learning, try to practicalize it. Pick a problem, practice what you have learned, and you are going to see how fast you are going to even learn more and become more professional within the shortest time possible. So this is also forming part of our important clarification series under the theme, always let the data speak. Always let the data speak. Later, we are going to be talking more on the issue of let the data speak. There will be several episodes on that. How can we let the data speak and what it entails, following a newly released book called Let the Data Speak, which we hope some of us already gotten it, and then hope others also we take benefit and also spread it to other people so that they can also take the benefit of how we can ensure we are doing the right thing and doing it right when it comes to using machine learning in data, for data modeling or in data science and analytics. Now, moving forward, a quick rehearsal of what we've covered. Iterative machine learning model building framework. This is what you always need. You have the data stage where you have your data. We have the data preparation. We have the feature engineering. We said in the line with the let the data speak principle, don't spend too much time here. Do what is utmost necessary as far as preprocessing is concerned and move to modeling. Because you have that privilege of going back. You can always go back. That's what we call it iterative. Iterative. A lot of people spend over 60 to 70% of their time on data preparation. That is what that book, Let the Data Speak, is set to correct, to clarify. See, there are better ways to handle that. Rather than spending 60 to 70% of your time on data preprocessing, that you realize later that some of those preprocessing you actually have done, they are not really necessary. They are not contributing, they may not contribute to your possibility of getting better results. In fact, what you may have ended up doing may be what we call data mutilation. Data mutilation. That is, you are mutilating the data to the extent that the one you are finally presenting or for your algorithm may not be the one that will provide the needed insight. This from practices, from experience, have been well documented in that book, Let the Data Speak. So once you have done the most important basic preprocessing, go to the algorithm, select your algorithm, like k-nearest neighbor, a friend, KNN, run the experiment with the default parameter, go back and do the iterative, whatever, go back and do the iterative system, which is well documented for us here in the modified iterative machine learning modeling framework to support Let the Data Speak. So this is where your first point of call is here. This is your first point of call, which is here. It's number one, where you go to. So do hyperparameter optimization. Change your K from K is equal to 1, which is the default. Change it to 3. Change it to 5. Check the one that is working for you. Thereafter, try to change the distance measure. And in short, do what we call hyperparameter optimization. You can check out our videos on our YouTube channel. What do we mean by hyperparameter optimization and how to do it? Or hyperparameter tuning optimization. Sometimes, even after doing the hyperparameter optimization, you may not get the best result you are expecting. You may need to change the algorithm. So this is time for you to try other algorithms like decision tree, support vector machine, naive Bayes, and a host of others. But don't remember, start from simple algorithm before you move to more complex and complicated algorithms. After that, if yet you are not getting what you are looking for, then you may have to go back. All the way back to data preparation again. Maybe you need to undo missing value, outlier treatment, reduce noise, removing duplicates, do a lot of pre-processing or feature engineering. You may have to normalize your data. You may have to do log transformation of your data, discretize. You may have to construct new attributes, which is one of the operations we do carry out under feature engineering. Use 2 attributes to formulate another new attribute that you think may perform. Use attribute 1 to multiply attribute 2 and call it new attribute 17. These are examples of what you do under feature engineering. Sometimes we may have to do feature selection, data reduction, data down, which we call feature selection, feature reduction, PCA, and also for others. And sometimes you may have to bring data consolidation, bring data from multiple sources so that you want the data to be more and also more representative of the environment we are modeling. Then you go back forward. When you do one, you do the modeling again and check the result. It's not yet good to your satisfaction, go back again and do another one. Keep doing one at a time and checking. And this is why one of the concepts we promoted is the idea of what we actually refer to as multi-channel pipeline. Multi-channel pipeline. It's well documented in our book called Let the Data Speak. In multi-channel pipeline, so every time we have pipeline, just like we have pipeline for water, pipeline for oil and for oil, we also have pipeline for machine learning modeling for data science. So it means in that pipeline, you set up all the operations. You have your data is coming in here, input the data here. You have, you need to do missing value, undo the missing value, the algorithmic modeling, the result, you have the output. The next line, this one is going to have the same data coming in, feature selection. Feature selection is part of this pipeline. We don't have feature selection here. We have feature selection here because we don't know which one is going to give us better result. So you create, then this AI, we are going to have log transform. We do log transformation for our data here. So another channel, you keep different pipeline. So you create as many pipeline. Whenever you do a pre-processing, a different pre-processing task that make your data to become totally new or modified, you generate a new pipeline for it. At the end of the day, you run. Sometimes you might have multiple pre-processing activity in one pipeline. So at the end of the day, you cannot compare the result from pipeline 1, pipeline 2, 3, 4, 5, 6. Finally, you are going to see one pipeline that has the best result for you. That is the one that you are going to select finally. Rather than sitting down to do all these pipelines in one go. At the end of the day, you are only going to be using your data in the final form after you finish all the pre-processing. And that data may have been mutilated in what we call data mutilation. You now have a data that is totally different from what you had in the original world. You see, at the end of the day, it may not produce good result for you. So why don't we do it gradually? Run the original data. The first pipeline should always have the original data. The first pipeline, nothing. If the data can run, let it run through the algorithm in the first one before you do any pre-processing. Even missing value, I usually tell people, when you have missing value in your data, go and use decision tree. The family of decision tree algorithm, they can model data even with the presence of missing value. Use decision tree to model your data and see what result you are getting, because it is natural to have missing value. If it can model well, even with the presence of missing value, so it is. So the first pipeline should always contain the natural characteristics of the data. And that is in line with the principle of letting the data speak. So once you are done, then try several other. So all those options we put here, all these options, normalize the data, log transform, each of them will form separate pipelines. There are so many ones. Feature selection, PCA. There are so many things you can do when it comes to data pre-processing and feature engineering. But as you implement one concept, try to generate a new pipeline. You see, so you have multi-channel pipeline. Then if you now compare the result from this pipeline, which one is giving me the best result? You go for it. You now build your final model based on the one that is giving you the best result. It may be this number 3 that is going to give you. No one knows. This is the idea we explain much in our book and our previous engagement. Now, so having done that, as a starter, let me remind us about this. Different angles to solving problems using AI-based solution. To the people from diverse background, clearly think and brainstorm about your area of specialization or interest and see how you could utilize machine learning modeling towards improved outcomes. This is very important. I want us to practice what we are learning immediately. Think of your area. If you have anything that interests you in your area, think of another area that interests everybody. I used to tell people like medical. You don't go to clinic, you have somebody that is going to clinic, or you have a friend that visits clinic. Think of what you can build for them. How can we make life more easier for a medical practitioner? It's not practically feasible for you to go around as a medical doctor to diagnose everybody out there who are not complaining. Meanwhile, one of the characteristics of chronic disease is that it takes time for the complaint to start. Because by the time the complaint starts, usually it's late stage. Medical practitioner in the house can testify to that. So that is why it's very dangerous to wait until disease progresses, especially chronic diseases. So why don't we think of, can we make early diagnosis for people? Classically, an organ of the body, one of the wonders of our Creator, is they are very, very unique. When an organ is affected by a disease, the capacity of the organ will keep increasing to take care of the abnormality that has occurred to it. Like maybe initially it was working at the capacity of 25%. When the organ has been attacked now by a disease, it increases its own capacity to 35, 45. As the disease keeps increasing, it will be destroying the organ gradually. This system has a kind of reserve. It keeps increasing the capacity until maybe it gets to like 90% capacity. At that point, 90% of the organs may be gone. And that is where the pain will start. We can check it out, we can read about it. Most chronic diseases, whenever the complaint starts, when they check, they notice it's already almost at the late stage. The question I ask is, why do we wait for late stage? And what can we do to prevent people from waiting till late stage? It's not possible to ask people who don't have pain to go to medical doctor to go and do tests. Just because, to be sure. Of course, people does it maybe once in a year. It is recommended to do medical check. Is it not the one that has eaten that is comfortable a little bit that does that? Even some people have money. They don't have the time to go for that medical checkup. Just the few minutes they are going to spend in the clinic to drop their blood for medical checkup, they don't have it. We now say, why don't we bring medical diagnosis close to everybody? Why don't we build a system for them that they don't even need to go to clinic to do any medical tests, like questionnaire-based medical diagnosis that we are currently working on a couple of projects on it. We want to see, especially in places where people are not financially buoyant, they may not have the money to do the medical tests to be able to diagnose earlier if they're having issues. However, if few questions could be asked from people already sick, confirmed sufferer of that disease, we bring it up and train a model based on those questionnaires that we can take it around. Anybody can just log into his own phone and try to diagnose him or herself to know earlier if they have a characteristics of a particular chronic disease so that they can seek for intervention before it graduated into the late stage, which is usually the characteristic of most chronic disease diagnosis. So when you have this kind of thinking, Look for data set. It's very simple. Go online. The starting place is for you to go online. You don't need to produce the data by yourself. Once you understand it, then you can start thinking of having your own natural data from your own environment. Pick data set from online and try to implement an idea. You want to diagnose diabetes. Try it out. See how it works. So once you do that, interest and see how you could utilize machine learning modeling towards improve outcome. Then further think of how you can improve upon your earlier achievement through coming up with more advanced machine learning algorithms or techniques like hybrid or ensemble modeling. You always have something to do to get it better. As you are finishing one, and the interesting thing about this idea and this field is the moment you try one, that one will motivate you to try others. And that is the beginning. Before you start, you know what is happening, you start thinking as a data scientist. You see, because it will be paining you that data is just wasting away. We are huge data wasting away. Why don't we bring it up and let us benefit from it as we try to use AI and machine learning in our day-to-day modeling. So this is for those people who are not from computer background. To those people from computer science related background, in that case also, you clearly think and brainstorm about areas that may be in dire need of improved outcome if provided with machine learning modeling. You see? So as a computer scientist or whatever name you have, the whole world is the civilization of the world is having computing as the pivot of civilization. It has been for a long time, and it is even becoming more and more with advancement in AI and the related technology. So we don't need to be a medical doctor before we build a system for them. We can collaborate with medical doctors. We can collaborate with engineers. Why do we need to wait for a cyber attacker to attack a national infrastructure that can bring down a catastrophic consequence? When you can have an AI predictive solution that can predict exactly when that attack may likely happen, and you can shut down the system. But the best way to prevent an attack is to bring the system out of network. That is the sure way. Tentatively disable that system at the point that the AI system has been able to recognize that this is going to happen, thereby preemptively avoiding a disaster. So there are a lot of areas in this respect. Why do we wait for a criminal to actually commit a crime when you can have a preemptive diagnosis or preemptive identification of potential threat in a neighborhood? You can map neighborhood appropriately and be able to detect. First of all, identify which neighborhood may likely suffer from criminal attack. And then you zero into houses in that neighborhood. These are possibilities that are already being used, being deployed. Further think of why can't we be proactive to prevent flood disaster? Why do we wait for the flood to happen when it is now possible for us to build systems that can predict a particular area that may suffer flood in the next couple of days? And then you can be able to send alerts to let people evacuate before the flood. And even in case of emergency response, you can use systems that can target aerially to be able to target the people that needed urgent need for evacuation more than the others. So in essence, as computers are related, people from computers are related background, the world is looking up to you to see how far you can go. Identify areas or problems where you can improve the life of human beings, fellow human beings. It doesn't have to be about a particular business, but finally it will lead to business for you because it is service provision. Country will look for you, state will look for you to come and help them build this kind of a system that can hopefully save life and prevent disaster. Also, you think of what you have done before and see how can I improve upon what I have done before. Also, one option there is also to develop new machine learning algorithms. Come up with new ones, hybrids. Try to mix existing systems together to generate new ensemble framework that have never been known before. So there are also for that a lot of stuff we can all relate to. Either you are from computer science background or you are not from computer science background. Everyone can relate appropriately and see how you can be able to benefit from the use of machine learning for modeling. Again, the unique thing I want us to note is that there could be so many diverse applications where you can put this machine learning for modeling into. However, a unique thing is that the application method is generic. C is generic. Generic in the sense that the same procedure you are taking to model for medical is the same procedure you're going to take when you want to model for civil engineering. When you want to model for chemistry, the same procedure you're going to take. When you're doing modeling for agriculture, which I remember we spent several weeks in the past trying to how can we use machine learning in crop production. Later, we did animal production also with practical demonstrations in weaker environment. So that uniqueness is the fact that the methods are generic. The methodology. So the same thing you deploy here, you just take it to another place and deploy it. It's only the data collection, the interpretation of result we have to be analyzed to make it sure that it is suitable or to suit the specific area we're analyzing. For example, in medical application, the major issue we don't want is false negative. False negative is when you say somebody is not sick, meanwhile he's sick. We don't want that kind of mistake. He's not sick, but you are saying he's sick, he will go for medical checkup and later they will clear him that he's not sick. That's a mistake we don't want, but it's a better mistake than when you say somebody is not sick, but meanwhile he or she is sick. He may develop complication. But in production system, when you deploy machine learning for quality control check, that's not false positive is the big issue. We don't want it. Because false positive is when you say that a product is okay, but it's not okay. You'll be sending product that is bad to your customer, who may take you to customer protection agency. It will take you to Twitter to badmouth your company, and then the company may go bankrupt. So false positive is a big issue when it comes to quality control monitoring modeling. But in medical, false negative is a big issue. So it's only when you are going to analyze the result, the output, that you have to analyze it to look at the actual cost of misclassification. The actual mistake, cost of mistake, it varies from areas of application to the other. But all other procedures, they are the same thing. So that is why when we are modeling or we are mentioning how to do it in civil engineering, for example, even people who are not from civil engineering should not say, oh, it's not my area. No, you can relate. The same procedure we are teaching in civil engineering, you just pick, it's like copy and paste with little modification to a new area of your specialization. Because one of those we are going to be looking up to, so as we move, is we're going to be looking into several areas based on request. See? So I'm based on for example, today now I'm going to ask us to do a poll. So before the end of this class, I want everybody to let us know. You chat in the chat box, tell us your area of specialization based on numbers. So we are going to be taking areas of specializations, and we're going to look at case studies to guide us how you can use machine learning modeling in your own area of specialization. So we already have some curated area that we want to deal with, but then we are going to be picking each one after the other. So today, before you leave, drop a message, your area of specialization. I mean, to social engineering. I mean, to animal production. We select it majority. Based on majority, we'll be guided based on those interests of our majority. But like I said, irrespective of which field we try to treat on a weekly basis, we can always relate with, because the method is generic. It's the same idea. It's only some, when you copy paste it, a little special modification you just need to do to suit your own area. So a couple of areas in the past we've dealt with is bankruptcy prediction. So imagine a predictive solution that can tell the government monitoring agency ahead of time that a particular company may go bankrupt. That is, the company may fold up. You don't wait for it to happen, because a company, private company that is employing thousands of people, so allowing it to bankrupt is going to affect not just an individual, several families. So a proactive government agency will have a bankruptcy system that continuously monitor every company, especially now they are encouraging you to have startup. It's not just enough to have startup, but we need to monitor the startup and prevent them from going off again after employing people. So once bankruptcy prediction model is able to identify a particular company that, oh, this company may bankrupt, then quickly the government can take over and run the company, deal with whatever. Usually human beings are usually the problem of establishment going bankrupt. Either they are missing their priority or whatever issue that are involved. So in this respect, if we can have a bankruptcy system that can work in such a way that will let us know ahead of time which company may have problem, the government will take it over, run the company until it becomes productive again, while keeping the staffs. And then before they return it back to another, maybe owner or the owner, they have to have a particular arrangement and deal. But this is what the word is being deployed and used in a lot of countries already. So, and they still need more, because they need more accurate bankruptcy prediction. So we also have the medical and biomedical related predictions and also for others that we're going to be picking from time to time, depending on our availability and time. So this is what we hope we can all move together. There are so many successful machine learning applications where you can focus, but the idea is we want you to practice what you are learning. Please practice what you are learning. This is very important. And like I said, applications are diverse, but methods are generic. The same method, you can always use it over and over, even in other different application areas. So because of our time, we will give time for little or any for questions and answer. And like I said, going forward, we are going to be giving more time to you to ask more questions starting from other ways. So start practicing what you are learning and keep writing down your questions for clarification. This is the way to move. This is the way to learn, so that together we can be able to see how far we can deploy and benefit from this unique technology, AI, machine learning, and their related field. Thank you very much for listening. I wish you all the best. Thank you.